Okay, hello again. Let's continue with solving quadratic equations. This time the method that we are going to use is called completing the square, which is actually a prelude method to solving the quadratic equation by formula, which is called the quadratic formula. That's basically what it is actually. The quadratic formula is basically a final product of the completing the square. All right, first, what is a couple of things we have to do. What is perfect square trinomials? Because we need that so that the concept of completing the square can make sense. So the concept of perfect square trinomial is very important, and that is where you have a trinomial. And remember, a trinomial, I guess I should explain what a trinomial is. If I have a trinomial that looks like this, trinomial. That's 1, 2, 3 terms, okay? So that's a trinomial, and it is a quadratic trinomial because it's a quadratic equation and it's a power of 2. If we can write this in terms of the bracket or a factor form, where both of those brackets, as you can see, the inside are exactly the same, that means we are making it as a power of 2. So the bracket, because they're both the same, we can just say ax plus c is a power of 2, and that is a quadratic. So if we can change the general form to this one bracket to the power of 2, that's called the perfect square. Now, perfect square is just like a perfect square number. What are the perfect square numbers? So perfect square numbers, you know that. So 2 squared, 4. So 4 is a perfect square number. What are the other ones? 9. What are the other ones? 16. And you see what I'm doing here. So you can go forever. So it's the same concept here, and that's what we're gonna use. Okay, so let's go ahead and do a few examples of that. So for example, let's look at first example is we want to know if this guy x squared plus 10x plus 25, is that a perfect square trinomial? Let's factor it. Okay, when we factor that, what do we get? We get x plus 5. Another way of writing it is x plus 5 all squared. So that is a perfect square trinomial. All right. Next one, let's do x squared minus 8x plus 9. Let's see if that is a perfect square trinomial. Okay. So two numbers you multiply, you get 9. And you add them, you get minus 8. So in this case, you can do plus minus 9 plus 1. And notice that these two brackets are different. So that is not a perfect square trinomial. Okay, so the perfect square trinomial must look like what this is. All right, let's do another one. X squared plus 16x plus 64. Is that a perfect square trinomial? Well, let's factor x plus 8, and two numbers you multiply, you get 64. You add, you get 16, and it has to be 8 again. Well, it is, because these two are the same, and then we can rewrite that as x plus 8 all squared. So you get the point. But here's the thing. There is a pattern that is showing up, and the pattern is this. Notice that there is a number, the constant number 25, and the constant number 64 is there. Now these, what kind of numbers are these? And we can just go ahead and look at other patterns as well. But these are actually perfect square numbers. So the constant term is a perfect square number. Okay? And that is your first sign that you have a perfect square trinomial. All right? And we can actually go ahead, actually create perfect square trinomial using that. All right, so let's look at an example. Suppose I give you this incomplete trinomial, and I ask you what should you add to this binomial to make it a trinomial that is a perfect square trinomial. Now this number here that we have, this whatever we're going to put here, this number has to be a perfect square. How are we going to get that? And here's the thing. If you go back and you notice that the middle number, this middle number is actually related to the constant number. This middle number, the coefficient of x, the linear, is related to that. Do you see the relation? Ooh, 5 plus 5 is 10. 5 times 5 is 25. 8 plus 8 is 16. 8 times 8 is 64. So what is happening here? Whoa, we can notice that we can actually break this up to 4 and 4 because the two numbers, the same two number, right? They add, you get 8. So when you multiply them, what do you get? You get 16. So it turns out that this guy should be 16. And that makes sense. When you do this, then you can factor that. And when you factor it, what do you get? You get x minus 4 and x minus 4. All right. So that is very important. So you look at the middle term, you break it up into 2, and then you create that. And now you just created a perfect square trinomial. Okay, let's look at example B, and now we're going to streamline this process now so they can see what's happening. So whenever you want to create a perfect square trinomial, you look at the coefficient of the linear term. Whatever it is, you divide it by 2 equal values. So 14 divided by 2 is 7. So very simply, you take this one, you divide it by 2, it becomes 7 and 7, and then you multiply them, you square it. So 7 squared is 49. And then when you set that up, and then you go through, you get x plus 7, x plus 7. So very easily, 14 divided by 2, whatever you get, you have to square it. That's what you would do. And then that would be the addition to the third term that you add to the binomial. And then you create a perfect square trinomial. All right. And by the way, I wrote it as a 2 brackets, but it makes sense to make it just like that. All right. Very simply.
Now let's look at example C. Now this example is harder than the other examples that we have done. Okay, so these other examples were a little bit easier because the coefficient of the square term, the quadratic term, was 1. All right, here is 1 and there is 1. So this was 1 and so is that one. And that's pretty easy to do. You don't have to do anything else except divide the middle term by 2 and then square it and add. And that becomes a perfect square trinomial, and therefore you have a binomial squared. But now we are going to look at this question right here where the leading coefficient is -3, and this value right in front, this -3 is actually needs to be removed so that we can continue and use the completing the square method, because with that -3 in front, completing the square method the way we use it will not work. Okay, so let's go ahead and do this now. The way you do this, you have to first factor the -3 out of the first two terms. Now, factoring out -3 out of 5, and that becomes 5 over -3. Okay, and if you don't know how to do that, make sure you review the factoring of integers. So basically, on a side, if -3, you multiply it by 5 over -3, what do you get? Well, you get 5 back. That's why -3, when you factor out of 5, you get 5 over -3. Now, another way of writing it is, instead of writing -3 in here, I could have just left this as a -5 in here, -5 over 3. I could have done that as well. But plus, and then I'm going to leave a space here because I have to add a number here that makes this a perfect square trinomial. Okay, so let's go ahead and let's see what we can do. Remember the rules. First, we're going to take half of -5 over 3. And half of -5, 3, remember, of means multiplication. So that means half times 5 over 3, that would be 5 over 6, and that's a negative. And then the next step, that's step 1. Step 2 is you get -5 over 6, and then you have to square it. Okay, you have to square that, and what will you get? Final answer is 25 over 36. Yeah, and it's positive, right? And then you take this 25 over 36 and you have to plug it back in here, 25 over 36. Okay, now you're not done yet because you have to be able to write this in terms of binomial squared. Okay, and to do that, so now I'm going to rewrite this down more so they can see it. So what do we have? We have -3 outside, we have x squared. By the way, there is an x in the middle to add that x in there. So I missed that x in the middle. It should have been an x in there. All right, so x squared minus 5 third x, and then plus 25 over 36. Okay, now that we have this, let's rewrite it. You're going to leave the -3 out, and now you are going to the factor form, but remember it's the easy one now. You just take the square root of the first term, so x squared, you put it in each of the brackets. If you want to know if the middle term of each of these brackets is positive or negative, you look at this sign right here, and you notice that that's negative. That means this sign right here has to be negative, and that has to be negative because it's a binomial squared. So we know that's going to be negative. So let's put a negative for both sides, and then you take the square root of that 25 over 36, or you use just that 5 over 6, but without the negative, because I already included the negative there. So you put 5 over 6 in here and 5 over 6 in there. And then you rewrite. Okay? What do you have? -3 outside, x minus 5 over 6, all squared. And now you have yourself a binomial squared, and this trinomial is a perfect square trinomial. Notice that this was a little bit involved because it involved fractions, and you had to pay attention to how you use fractions, especially with algebraic operation and squaring and adding and subtracting, stuff like that. But that's how you will do it, because not all the questions are straightforward. I mean, obviously, fractions are a little bit more involved and you have to pay attention to that, but here it is. The concept is the same, exactly the same. All right, so we just took it to another level. I hope you found this useful. If you did, like, comment, and subscribe, and hit the notification bell, so whenever I have a new video up, you can access it right away and you'll be notified. All right, until next time, keep at it.